Okay, so now after combining the data from laptops data table and point of sales data table, we can see that now the point of sales data table are filled up with the laptop specifications, laptop components which are obtained from the laptop's data table dataset. And now what we are going to do is to analyze the distribution of laptop components in a certain retail price. So we're going to do this distribution analysis by putting the laptop specs and the retail price. So now we can see all these are the laptop components, and then we also included the retail price, and it also can be seen that the retail price is distributed is following a normal distributions. And at one glance, we can observe the most and the least popular components. So for the HD size, we can see that 300 gigabyte is the most popular one overall, while the 40 gigabyte is the least popular. Same goes to battery life. 6 hours is the most popular and 4 is the least popular. 2 gigabyte of RAM is popular one, and 4 gigabyte of RAM is not so popular, and 2 gigahertz of processor speed is the most popular one, while the 2.4 gigahertz is not so popular. For the screen size, 15-inch is of course more popular than 17-inch screen size. And of course, if we are customers, we also want integrated wireless and freebies bundled applications as well. So the question now is, how do we analyze what does a customer wants in a certain price range? What are the customer buying preferences? If let's say they want to buy a laptop with a high price or medium price or low price. So what we can do is we can look at the distributions of point of sales or the transactions, distribution of the retail price in a particular in this point of sales data set. So we can see that it follows a normal distribution, and in addition we can see that the quantiles are all here. And from this quantile, we can separate the retail price, the range of retail price, into four particular groups. So the first group will be anything that is lower than the first quartile. The second group, which is the lower medium price range, will be from Q1 to Q2, and then the upper medium price range will be from Q2 to Q3, and then everything after Q3 is considered as high priced tier. So we can do multivariate analysis in this distribution analysis function as well by highlighting particular data point. So in this case, if you want to highlight Q3 onwards, we can do things like this. So we can select all the data sets that are considered higher than Q3. So in this case, Q3 is 530, so everything above it will be considered as high price tier. So at one glance, we can see all the related data with retail price higher than 530. But the problem with this is that although we can straight away see what are the proportions of data which is related to high price tier, but we couldn't exactly see what are the percentage of what are the proportions of this shaded area. So what are we going to do now is to add one more column called price tier column, which include all the different price tier. So this will be the price tier column that I have added. So what this price tier column have is this formula, in which it says that if the retail price is more than 530, it is considered as high price tier. If it's more than 475, which is the Q2, and less than the Q3, it is considered as upper medium. Else, if the retail price is more than or equals to 435, which is the Q1, and less than the Q2, it is considered as lower medium, and otherwise it will be considered as low price tier. So after applying this formula, we can get a new column with all this price tier information.